Imagine a planet where sharp glass rains down at over 7,000 kilometers h, another that shines like a giant diamond, and one so close to its star that it is evaporating before our eyes. Think of a world covered by an infinite bottomless ocean, or a giant with rings 1,000 times larger than Saturn's, visible in our sky like an arch that would dominate everything. There are planets that float alone in the void, without a star, wandering like cosmic ghosts, and others that could harbor life right now, just 4 light-years from Earth. All of this is not science fiction. They are real exoplanets, discovered by our telescopes. Get ready, because what you are about to see today surpasses any movie, any myth, and any preconceived notion you have of the universe. And yet, it is just the beginning. When we talk about exoplanets, we refer to worlds that orbit stars other than the Sun. But what makes them so special and different from the planets we know in our own cosmic neighborhood? The word exoplanet comes from exo, meaning outside, and planet. So they are literally planets outside the solar system. If you've ever looked up at the night sky and wondered if any of those stars might have another world like Earth, the answer is yes. Exoplanets are the proof of that. How do they really differ from the planets in our system? For starters, exoplanets can be incredibly varied. Some are gas giants much larger than Jupiter, while others are small and rocky like Earth, or even denser than lead. There are also those that orbit so close to their stars that a year lasts only a few hours, while others are so far away that they almost seem like wandering planets, drifting in the darkness. Unlike the planets that orbit the Sun, these bodies revolve around other suns, each with unique characteristics that challenge our imagination. A common question is, why are we so fascinated by these distant worlds? The answer goes beyond simple curiosity. Exoplanets allow us to understand how common, or rare, life might be in the universe. Each discovery is like opening a mysterious envelope sent from another part of the galaxy. Could there be an exoplanet covered in endless oceans? Will there be one with atmospheres dense enough to crush any ship attempting to land? Moreover, the study of exoplanets forces us to rethink what we consider normal in a planet. Before discovering them, we believed that planetary systems should resemble ours, but reality has proven to be much stranger and more fascinating. There are exoplanets so hot that their surfaces are covered in lava, others so cold that ice is harder than steel, and some with orbits so eccentric that they defy all previous theories about how planets form. Thus, each discovered exoplanet is another piece in the gigantic puzzle of the universe.
If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey.
Have you ever wondered how the search for planets outside our solar system began? For centuries, humanity looked to the sky, wondering if there were other worlds orbiting distant stars. However, until just a few decades ago, the existence of exoplanets was pure speculation. Astronomers did not have the technology or methods necessary to confirm that, indeed, there are other planets beyond the Sun. What was the exact moment when we stopped imagining and started discovering? In the early 1990s, an unexpected turn occurred. In 1992, astronomers Alexander Wolszczan and Dale Frail announced the discovery of 2 planets orbiting a pulsar, a neutron star called PSR B1257+12. This finding baffled the scientific community. How could planets exist in such a hostile environment, around a star that had previously exploded as a supernova? The surprising thing is that these first exoplanets did not orbit a star similar to the Sun, but rather an extremely dense and violent stellar remnant. It was like finding an oasis in the middle of a radiation desert. It didn't take long before an exoplanet was discovered around a star more similar to the Sun. In 1995, astronomers Michel Mayor and Didier Queloz detected 51 Pegasi b, a giant gas planet located in the constellation Pegasus. This discovery revolutionized astronomy as it confirmed that planets can form and survive around common stars. 51 Pegasi b was not a traditional Jupiter. It orbited incredibly close to its star, completing a revolution in just 4 days, which was completely unexpected according to the theories of the time. Why would such a large planet be so close to its star? This finding forced scientists to rethink many ideas about the formation of planetary systems. From these pioneering discoveries, the search for exoplanets accelerated. Each new finding brought with it new questions and challenges for science. Astronomers began to use increasingly sophisticated telescopes and techniques, discovering that the universe is filled with strange and varied worlds. How many exoplanets might there be in our galaxy? Current estimates suggest that there could be billions of all imaginable sizes and characteristics. What began as a curiosity transformed into one of the most dynamic and fascinating branches of modern astronomy. These early discoveries not only expanded our knowledge of the cosmos, but also forever changed our perspective on the place we occupy in the universe. Knowing that there are other planets, some perhaps with conditions similar to those on Earth, invites us to dream and wonder if, in some distant corner, there could be life. The era of exoplanets had just begun, and with it, one of the most exciting scientific adventures of our time. How do we know that there are planets outside our solar system, if, even with the most powerful telescopes, we cannot see them directly? The answer lies in the creativity of science. Exoplanets are often invisible because their stars eclipse them with light thousands of times more intense. However, astronomers have devised ingenious methods to detect them, even without seeing them directly. One of the most commonly used methods is transit. It involves observing how the light from a star decreases in a regular and periodic manner. Why does this happen? When an exoplanet passes in front of its star, from our point of view, it blocks a tiny fraction of its light, as if a small speck of dust were passing in front of a light bulb. This drop in brightness reveals not only the presence of the planet, but also its size, and in some cases, clues about its atmosphere. But what if the planet doesn't pass directly in front of the star? Scientists have found another technique, radial velocity. This method is based on the wobble that a star experiences due to the gravity of an orbiting planet. Even though the planet is invisible, its attraction causes the star to move slightly back and forth. This tiny movement, imperceptible to the naked eye, produces changes in the star's light that can be detected with very precise instruments. It's like noticing that a person walks oddly because they are carrying a very heavy backpack, even though you can't see the backpack directly. Are there other ways to discover these distant worlds? Surprisingly, yes. One of the most fascinating methods is gravitational microlensing. In this case, the gravity of an exoplanet and its star acts like a cosmic magnifying glass, amplifying the light of an even more distant star. If the alignment is perfect, the brightness of the background star increases characteristically for a brief period. Although this method is rare and requires almost miraculous alignment, it has allowed the discovery of planets that would otherwise be impossible to detect. There are also techniques like astrometry, which seeks to measure the exact displacement of a star in the sky due to the gravitational influence of a planet, and direct imaging, which, although extremely difficult, has managed to capture the light of some giant exoplanets thanks to advanced technologies that block the light from the central star. Each method has its advantages and limitations, but together they have opened an incredible window to the discovery of thousands of exoplanets. Who could imagine that? Without seeing them directly, we could learn so much about these distant worlds just by observing how they affect their stars. The search continues, and with each new technique, the universe reveals a little more of its secrets. What if I told you there was a planet that forever changed the way we see the universe? That planet is 51 Pegasi b, known by many as the pioneer among exoplanets. Before its discovery, the idea of finding planets outside the solar system seemed almost science fiction. But in 1995, a group of astronomers led by Michel Mayor and Didier Queloz announced that they had detected a planet orbiting a sun-like star about 50 light-years away. What was special about this finding? It was not only the first of its kind, but it also shattered almost all expectations of how planetary systems should be. 51. Pegasi b is a gas giant, similar in size to Jupiter, but with one major difference: it orbits incredibly close to its star, much closer than Mercury to the Sun. Can you imagine a planet the size of Jupiter completing an orbit around its Sun in just 4 Earth days? It's as if we placed Jupiter in Mercury's orbit and accelerated time to extreme levels. These types of planets, known as hot Jupiters, were completely unknown before this discovery. Scientists thought gas giants could only form far from their stars, but 51 Pegasi b proved that the universe can be much more creative than we imagined. But how was it possible to detect such a distant and strange planet? This is where a revolutionary technique called the radial velocity method comes into play. Astronomers observed that the star 51 Pegasi was moving slightly back and forth, as if something invisible was pulling it with a string. That pull is caused by the planet's gravity, which makes the star wobble almost imperceptibly. Measuring those tiny movements allowed them to deduce the presence of the planet, its approximate mass, and the speed at which it orbited. This method became one of the most powerful tools for discovering exoplanets and opened the door to one of the most fascinating fields of modern astronomy. Why does this planet continue to fascinate scientists nearly 3 decades after its discovery? Because it completely changed the rules of the game. The existence of 51 Pegasi b forced a re-evaluation of theories about how planetary systems form and evolve. If a gas giant can be so close to its star, what other surprises does the galaxy hold for us? The case of this pioneering planet not only taught us to look beyond the known, but also ignited the spark of a true revolution in the search for other worlds. Is it possible for a planet to have 2 sunsets? Although it sounds like science fiction, Kepler-16b is the living proof that the universe can always surprise us. This exoplanet, discovered in 2011, orbits around 2 stars, forming a binary system reminiscent of the mythical Tatooine from Star Wars. But, unlike the famous saga, the reality of Kepler-16b is even more fascinating. Its orbit causes it to experience double sunrises and sunsets, creating a cycle of light and shadow completely different from anything seen on Earth. How can a planet maintain a stable orbit between 2 suns? The answer lies in the perfect gravitational dance performed by its host stars. Kepler-16b does not orbit around one star, but around both at the same time, following an almost circular trajectory. This phenomenon, known as a circumbinary orbit, challenges our intuitions about how planetary systems work. Can you imagine what this would mean for the climate and the cycles of day and night? The calendar on Kepler-16b would be radically different, with variations in sunlight much more complex than what we experience here. Another intriguing question is, how did such a peculiar planet form? Scientists believe that the creation of a circumbinary world requires extremely precise conditions. The gravitational forces of 2 stars can be chaotic, making it difficult for protoplanetary material to clump together to form planets. However, Kepler-16b defies that apparent obstacle and demonstrates that nature can find unexpected paths. Its existence suggests that double planets could be more common than we imagine, expanding the possibilities of finding habitable worlds in unexpected places. In terms of its physical characteristics, Kepler-16b is a gas giant similar to Saturn, but with a probably cold atmosphere, as its stars are smaller and less luminous than the Sun. Despite its spectacular appearance, the extreme temperatures and composition of the planet make the presence of life as we know it unlikely. However, the discovery of Kepler-16b opened a new window for astronomy, demonstrating that solar systems can be much more diverse and exotic than we ever imagined. What other secrets await us among the double stars of the cosmos? Could there be a place in the universe where the weather is so extreme that rain is not made of water, but of liquid glass? This is the case of HD 189733b, one of the most astonishing and terrifying exoplanets ever discovered. Located just over 60 light-years from Earth, this gas giant has fascinated astronomers with its intense blue color, reminiscent of our own planet. But don't be fooled by its appearance. While Earth owes its color to the oceans, the blue of HD 189733b is the result of a toxic and hostile atmosphere. What makes this planet so special? For starters, it is so close to its star that it completes an orbit in just 2 Earth days. This extreme proximity causes surface temperatures of over 1,000 degrees Celsius, much hotter than any desert on Earth. But the most incredible thing happens in its atmosphere. Winds can exceed 7,000 kilometers per hour, speeds so immense that they would blow away anything in their path. Can you imagine a wind capable of crossing the European continent in less than an hour? However, what is truly fascinating and terrifying is the type of rain that falls on HD 189733b. Instead of drops of water, this planet experiences rain made of tiny shards of molten glass, formed by the condensation of silicate at extremely high temperatures. These pieces of glass are swept along by lateral winds at supersonic speeds, crossing the planet from side to side like microscopic cannonballs. If you could be there, each storm would be an apocalyptic spectacle where the sky hurls millions of hot glass needles, an absolutely lethal environment for any form of life we know. But how has something so exotic been discovered from such a distance? Astronomers have been able to analyze the atmosphere of HD 189733b thanks to transit observations, studying how the light from its star filters through the planet's atmosphere. Thus, they have detected the presence of silicate particles and deduced the existence of this glass rain. This finding demonstrates that, in the universe, reality can surpass science fiction. There are worlds where the weather is so radical that it challenges our imagination and redefines what we understand as rain. HD 189733b reminds us that exoplanets can be as beautiful as they are deadly, and that there is still much to discover in the far reaches of the cosmos. What happens when a planet ventures too close to its star? WASP-12b is the answer to this fascinating question. This exoplanet, located over 1,000 light-years from Earth, has captivated astronomers for a disturbing reason. It is being slowly devoured by its host star. WASP-12b is so close to its Sun that it completes an orbit in just over 1 Earth day. In fact, it is so near that gravitational forces are stretching and deforming it, giving it an oval shape, like a cosmic rugby ball. This extreme attraction causes its atmosphere to be stripped away and absorbed by its star, in a process reminiscent of a drop of water sliding and disappearing down a sink. Can you imagine a planet so close to its star that it barely has time left to exist? WASP-12b has temperatures exceeding 2,500 degrees Celsius, enough to vaporize metals and cause its atmosphere to expand, creating a giant cloud of gas and dust that envelops both the planet and its Sun. Scientists have detected that this cloud is so dense and extensive that it blocks much of the starlight, making the system even more mysterious. It is estimated that WASP-12b could be completely lost in just a few million years, a mere breath in the scale of the universe. But why does this extreme phenomenon occur? The key lies in the proximity between the planet and its star. The gravitational tides are so intense that they continuously strip the planet of its outer layers. It is a perfect example of what astronomers call a hot Jupiter, although in this case, the word hot falls short. If we could observe it up close, we would see how the material from the planet forms a kind of gas bridge that falls directly onto the star's glowing surface, like a river of matter inexorably flowing toward its destruction. Could WASP-12b teach us something about the future of other planets, perhaps even the fate of worlds like Earth? While our planet is safe for now, studying these extreme systems allows us to better understand the forces that shape and, at times, destroy planets. WASP-12b is a reminder of how dynamic and violent the universe can be, and how, even in the most remote corners, there are stories of survival and destruction that challenge our imagination. Could there be a planet so dark that it doesn't even reflect the light from its own star? TRES-2b is the answer to this astonishing question. Discovered in 2006, This exoplanet has left astronomers perplexed due to a unique and baffling characteristic. It reflects less than 1% of the light it receives. To put it into perspective, coal reflects more light than Tris 2b. And if we compared it to a paved road on a moonless night, the planet would still be darker. How is it possible for an entire world to be almost invisible even to the glow of its sun? This exoplanet orbits a sun-like star located about 750 light-years from Earth in the constellation Draco. Tris 2b is a gas giant, similar in size to Jupiter, but its atmosphere makes it one of the most enigmatic objects ever observed outside the solar system. Scientists believe that the cause of its extreme darkness lies in the composition of its atmosphere, possibly rich in sodium, potassium, and titanium oxides, elements that absorb light rather than reflect it. But why don't its clouds light up like those on Jupiter or Saturn? One explanation is the absence of reflective ammonia clouds, which prevents light from bouncing off and giving it the typical brightness of other gas planets. Despite its gloomy appearance, Tris 2b is anything but cold. Its proximity to its star heats it to temperatures exceeding 1000 degrees Celsius. Imagine a world where the atmosphere boils, yet remains shrouded in almost total darkness. Even if someone could get close, they would see nothing more than a faint reddish glow, like the embers of a dying campfire. This combination of extreme heat and absolute darkness makes it one of the most inhospitable and mysterious places known to science. The existence of Tris 2b challenges our understanding of how planets and their atmospheres behave. Could there be other worlds even darker waiting to be discovered? What other secrets do exoplanets hold in the farthest corners of the galaxy? Each finding like this reminds us that the universe is full of surprises, and that sometimes reality far exceeds imagination. Tris 2b is proof that even in the most absolute darkness, science can shed some light. Is it possible for there to be a planet completely covered in water, with not a single centimeter of dry land? GJ 1214b, known as a water world, forces us to rethink almost everything we believe we know about planets outside our solar system. This exoplanet, located about 40 light-years from Earth in the constellation Ophiuchus, has fascinated astronomers since its discovery. Its size is approximately 2.6 times that of Earth, placing it in the category of a super-Earth. But what really sets it apart is its composition. What makes GJ 1214b so special? Everything indicates that it is largely composed of water, but not in the way we know it on our planet. The conditions there are so extreme that water can exist in completely strange states. Imagine a deep, dark ocean, where the pressure is so immense that water could turn into hot ice, a type of ice that forms not from low temperatures, but from such intense pressure that the water molecules arrange themselves into solid structures, even at hundreds of degrees in temperature. Above this ocean, it is believed there exists a dense, humid atmosphere, primarily composed of water vapor and possibly clouds of exotic particles. Could there be life in such a radically different environment from Earth? Scientists have wondered this, as the presence of water is one of the fundamental requirements for life as we know it. However, the surface of GJ 1214b is subjected to temperatures around 200 degrees Celsius, which would make the existence of Earth-like organisms practically impossible. But the mere fact of finding a planet with so much water suggests that the universe could be filled with worlds completely foreign to our experience, where life, if it exists, would likely be very different. The atmosphere of this exoplanet is also puzzling. Studies conducted with space telescopes have revealed that the light passing through the atmosphere of GJ 1214b shows signs of water vapor, confirming the presence of this compound in large quantities. However, observations also indicate that the atmosphere is murky, possibly due to the presence of clouds and mists rich in complex molecules. What hidden secrets could a planet wrapped in vapor, with endless seas and not a hint of dry land, hold? GJ 1214b remains one of the most mysterious and promising exoplanets for understanding the diversity of worlds that exist beyond our solar system. In short, GJ1214b demonstrates that water planets are not just a fantasy of science fiction, but a reality in the cosmos. Its existence raises profound questions about the limits of habitability and the true variety of forms a planet can take. As technology advances and new observational instruments are developed, astronomers hope to unveil more details about this fascinating aquatic world and perhaps discover if in some corner of its vast liquid surface, some form of life that we have yet to imagine could exist. What if there were a planet outside the solar system that had even more favorable conditions for life than Earth itself? Kepler 438b has been highlighted by many astronomers as one of the most promising exoplanets in the search for habitable worlds. This planet orbits a red dwarf star, about 470 light-years away, in the constellation Lyra. Why has this particular world captured the attention of the global scientific community? Kepler 438b is only about 12% larger than Earth, making it an ideal candidate for comparison with our own planet. Additionally, it lies within the so-called habitable zone of its star, a region that is neither too hot nor too cold, where liquid water could exist on the surface. It's as if nature has fine-tuned the conditions to create the perfect environment, at least in theory. But is it enough to be in the habitable zone for a planet to be truly suitable for life? The answer is more complex than it seems. Although Kepler 438b receives a similar amount of energy to what Earth gets from the Sun, its parent star is much more active. Red dwarfs often emit flares and radiation that could erode the atmosphere of any nearby planet. Could life develop under such constant bombardment? Scientists are still debating whether Kepler 438b has a dense enough atmosphere to protect its surface, or if it is doomed to be a barren and sterile world. However, what is fascinating is that despite these challenges, Kepler 438b represents one of the best examples of what we might call a habitable super-Earth. If the atmosphere and magnetic field are sufficient, it could host oceans, clouds, and perhaps even a stable climate cycle. The mere possibility that there exists a planet so similar to ours, but perhaps even more suitable for life, raises profound questions. Are we truly unique in the cosmos? Or are there other worlds, like Kepler 438b, waiting to be discovered and studied, ready to challenge our idea of what a habitable planet means? What would happen if a planet could survive the death of its star? This question, which seems straight out of science fiction, finds a surprising answer in the case of Kepler 70b, one of the most extraordinary exoplanets ever detected. Kepler 70b orbits a star that, millions of years ago, went through a phase of expansion so brutal that it would have destroyed any normal world around it. However, this planet not only survived, but also emerged transformed, as if it had passed through the interior of a stellar furnace and come out the other side. How is it possible that Kepler 70b withstood a stellar explosion? To understand this, we must first imagine what happens when a star like our Sun exhausts its nuclear fuel. It swells, becomes a red giant, and engulfs nearby planets, disintegrating everything in its path. Kepler 70b, along with another planet called Kepler 70c, was close enough to have been destroyed, but instead, both managed to remain in orbit, albeit at incredibly small distances from their current star, which is now a hot subdwarf. What temperatures does Kepler 70b face? This planet is one of the hottest known, with surface temperatures exceeding 7,000 degrees Celsius, even hotter than the surface of many stars. In such an environment, metals would melt and rocky materials would evaporate. The proximity to the star is so extreme that Kepler 70b completes an orbit in just a few hours, meaning that a year on that planet lasts less than a terrestrial day. It's as if gravity and heat keep it glued to the edge of a cosmic boiler, defying all expectations of planetary survival. What does the existence of Kepler 70b teach us? This planet represents an anomaly that challenges traditional models of planetary formation and destruction. Its mere presence indicates that, under certain conditions, planets can defy stellar cataclysms and persist in extreme conditions. The story of Kepler-70b is a lesson in cosmic resilience. Although the universe is hostile and chaotic, sometimes survivors emerge capable of withstanding even the fury of a dying star. This exoplanet is not only a testament to the diversity of the cosmos, but also a reminder that there is still much to discover about the resilience of worlds beyond our solar system. Can a planet really challenge the basic rules of planet formation? HD 106906b is a fascinating example that has left astronomers around the world perplexed. This exoplanet was discovered in 2013, and since then, its strange location and characteristics have raised more questions than answers. HD 106906b is not only gigantic, about 11 times the mass of Jupiter, but it also orbits at an incredibly distant distance from its parent star, more than 650 times the distance between Earth and the Sun. To put it in perspective, if our solar system were a neighborhood, HD 106906b would be the house several blocks away, yet technically still part of the same neighborhood. How can a planet form so far from its star? According to traditional theories, giant planets should be born close to their stars, within a disk of dust and gas, and then perhaps migrate a bit. But the distance of HD 106906b challenges this logic. Some scientists believe it may have formed much closer to its star, and for some reason was expelled to the outskirts of the system, possibly due to gravitational interaction with other massive bodies. Others suggest it could have formed similarly to a star, from the direct collapse of a gas cloud, placing it in the blurry boundary that separates a planet from a brown dwarf. What if this exoplanet is actually a rogue planet, almost a kind of galactic wanderer? The orbit of HD 106906b is so wide and eccentric that some astronomers wonder if it could, in the future, completely leave the stellar system it belongs to. It's as if it's on the verge of escaping, floating in a kind of gravitational limbo, undecided whether it belongs to the system or is destined to wander alone through the galaxy. This possibility opens up a range of new questions. How many planets like this exist in the universe? Is it possible that rogue planets like HD 106906b are more common than we think, simply too difficult to detect? The case of HD 106906b not only challenges theories about how planetary systems form and evolve, but also forces us to rethink our definition of what a planet is. Can the boundary between planets and stars be as blurry as it seems? Every new piece of data about this distant world adds another piece to a cosmic puzzle that, for now, remains incomplete. The truth is that HD 106906b represents one of the most intriguing mysteries of modern astronomy, and its study promises to forever change our understanding of the diversity and dynamics of planetary systems in the universe. In the vast catalogue of exoplanets, there are a couple that have left astronomers puzzled: Kepler-36b and Kepler-36c. What makes these two worlds special? They are so close to each other that if they were planets in the solar system, they would be closer to one another than Mercury and Venus. However, the true rarity lies not only in their proximity, but in how radically different they are. How is it possible for two bodies that share almost the same orbit to be so distinct in composition and characteristics? Kepler-36b is a rocky planet, just a bit larger than Earth, with an extraordinarily high density. Imagine it as a compact sphere, rich in metals and minerals, where a spoonful of its material would weigh much more than on our planet. On the other hand, Kepler-36c is a gas giant, with a mass similar to that of Neptune, but much less dense. It's as if, instead of finding two similar neighbors, one is a solid rock and the other is a swollen ball of gas. What processes could have led to the formation of such disparate planets sharing the same orbital region? The most intriguing aspect of this duo is how their orbits come within a minimum distance of just over 1.5 million kilometers, barely 5 times the distance between Earth and the Moon. In astronomical terms, that's practically door to door. Every 97 days, these planets pass dangerously close to each other, causing intense gravitational interactions. As a result, their orbits exhibit variations and small perturbations that resemble a delicate cosmic dance, where a slight deviation could disrupt the stability of both. Could these planets have been born so different, or did one of them lose its atmosphere in the past? Scientists suspect that Kepler-36c may have been an even larger gas giant, and that, due to its proximity to its star and interactions with its neighbor, it lost a significant part of its envelope. Others suggest that simultaneous formation in the same area is, in itself, a challenge to existing theories of planetary formation. Kepler-36b and c are, ultimately, a perfect example that the universe is capable of surprising us, even when we think we have seen it all. Can a planet rotate in the opposite direction to its star? Although it may seem incredible, the answer is yes, and the best example is WASP-17b. This exoplanet challenges what we had long taken for granted about the formation and evolution of planetary systems. While most planets, including those in our solar system, orbit in the same direction as their stars rotate, WASP-17b does exactly the opposite. It's like a highway where all the cars are moving in one direction, and suddenly one appears traveling the other way. How is something like this possible? WASP-17b is a gas giant, similar to Jupiter, but much larger and with a surprisingly low density. In fact, it is considered one of the least dense planets ever found, with a size approximately double that of Jupiter, but with only half its mass. It would easily float in a giant bathtub if such a thing could exist. But what really makes it extraordinary is the orientation of its orbit. Instead of following the spin of its star, it defies it and rotates in the opposite direction. This peculiarity, known as a retrograde orbit, has led astronomers to wonder what catastrophic event could have disrupted its original trajectory. Could a collision with another massive body have altered its orbit? It is one of the most accepted hypotheses. Scientists believe that, at some point in its history, WASP-17b may have gravitationally interacted with another nearby planet or star. This interaction would have been so violent that it radically changed its path, pushing it to move in the opposite direction around its star. These types of inverted orbits not only challenge intuitive logic, but also test traditional models of how planetary systems form and evolve. The existence of WASP-17b and its strange way of orbiting reminds us that the universe is full of surprises and that there is still much to discover beyond what we consider normal. How many other planets could be defying the rules we thought were universal? This exoplanet is living proof that, in astronomy, every discovery can completely change our view of the cosmos and open new questions about the origin and fate of the worlds out there. Is it possible for a planet to be as cold as the vacuum of space itself? Ogle 2016 BLG 1195 LB, nicknamed by some scientists as the Galactic Hoth in reference to the famous science fiction saga, is considered the coldest exoplanet ever identified. This world is located about 13,000 light-years from Earth, towards the center of the Milky Way. Unlike most exoplanets that orbit close to their stars and experience hellish temperatures, Ogle 2016 BLG 1195 LB is so far from its host star that in fact the light and heat it receives are minimal, comparable to what Pluto receives from the Sun. How cold can this exoplanet get? Astronomers estimate that its surface temperature hovers around -200 degrees Celsius, an environment in which any water molecule would freeze instantly. To put it in perspective, being on its surface would be far more lethal than any winter we can imagine on Earth. If you have ever felt the chill of a particularly frosty day, think that here, even the nitrogen in the air would turn into solid ice. It's a place where heat is so scarce that life, at least as we know it, would be virtually impossible. How was such a remote and dark world discovered? Ogle 2016 BLG 1195 LB was found thanks to an extraordinary phenomenon called gravitational microlensing. When a star and its planet pass in front of another distant star from our point of view, the gravity of that system acts like a cosmic magnifying glass, amplifying the background light and allowing astronomers to detect bodies that would otherwise be invisible. This method is especially effective for discovering distant and cold planets, far beyond the reach of traditional transit or radial velocity techniques. But why is it so fascinating to find such an inhospitable and frozen planet? The answer is simple. Ogle, 2016, BLG 1195. LB challenges our ideas about the formation and variety of planetary systems. Its existence suggests that planets similar to the icy giants of our solar system can form and survive even in the most inhospitable corners of the galaxy. Furthermore, it reminds us that the universe is full of extreme worlds, and that each one, no matter how cold or distant it may seem, contributes a fundamental piece to the puzzle of planetary diversity. What would you think if I told you that there are planets orbiting a dead star? That's right. The first confirmed exoplanets did not orbit a star like our Sun, but a pulsar, an ultra-dense remnant of a supernova. The pulsar PSR B1257+12 is a neutron star spinning at a dizzying speed, emitting regular pulses of radiation as if it were a cosmic lighthouse. But what's truly astonishing is that at least 3 planets are found around it. How is it possible for worlds to exist in such an extreme and hostile environment? To understand the rarity of this system, one must first imagine the hell that a supernova represents. When a star explodes in this event, it releases enough energy to devastate anything nearby. However, in the case of the pulsar PSR B1257+12, some planets managed to form afterward, or even survived the explosion. These planets, known as pulsar planets, are true cosmic survivors. There is nothing like it in the solar system. It's as if Earth orbited the glowing remnants of a star that was once 1,000 times larger than the Sun. What are these planets made of? Could they harbor life? Scientists have determined that these worlds are likely rocky, but the radiation they receive from the pulsar is so intense that any kind of atmosphere or life as we know it would be impossible. The conditions there are so extreme that even the most resilient materials on Earth could not survive for long. It's a natural laboratory to test the limits of planetary physics, extremely low temperatures, lethal radiation, and a completely different energy source than sunlight. This discovery completely challenged theories about planetary formation. Before PSR B1057+12, no one imagined that planets could form in the debris of a stellar explosion. What does this tell us about the universe? That nature is capable of creating worlds even in the most unlikely places, and that planetary diversity goes far beyond what we ever thought. Pulsar planets are proof that in the cosmos, the rules are made to be broken. What if I told you there is a planet where the ground is, literally, an ocean of molten rock? That's Kepler-10b, one of the most extreme and fascinating exoplanets ever discovered. This world is so close to its star that its year lasts less than a single Earth day. But the most shocking aspect is its surface temperature, which exceeds 1,500 degrees Celsius, enough to melt any known material on Earth. What would it be like to walk on its surface? In reality, it would be impossible. You would be standing on a sea of incandescent lava, where rocks boil like water in a pressure cooker. Kepler-10b was one of the first rocky exoplanets detected outside the solar system, and it is considered a kind of hellish twin of Earth. However, the differences are staggering. While our planet is covered in oceans of water, there is no trace of refreshing liquids on Kepler-10b. It is all extreme heat, and the atmosphere, if it exists, must be incredibly thin or composed of toxic vapors. Why is this planet so close to its star? Astronomers believe that Kepler-10b migrated from a more distant region, or perhaps it formed there and survived the violent early stages of the stellar system. Could there be any form of life in such a hostile environment? It is one of the most intriguing questions posed by Kepler-10b. So far, the answer seems to be no. The extreme conditions make it practically impossible for complex molecules necessary for life to form, at least as we know it. However, this world serves as a natural laboratory to study how planets can evolve in extreme environments and how gravitational forces and radiation can completely transform a rocky planet. The discovery of Kepler-10b forces us to rethink our ideas about what a rocky planet is. Not all solid worlds are welcoming, and some, like this one, seem to have come straight out of a volcanic nightmare. Could there be more planets like this, hidden among the stars? Undoubtedly. Kepler-10b is a sample that the universe is full of surprises, and that planetary diversity is much greater than what early astronomers imagined. Every time we find a world like this, we not only learn more about the cosmos, but we also discover how special our own planet is. What would happen if an entire planet were disappearing before our eyes? Kepler-1520b is a unique exoplanet that is experiencing a truly dramatic fate. It is disintegrating at such a rate that we could say we are witnessing its evaporation in real time. This world orbits so close to its star that surface temperatures reach extreme values, enough to vaporize solid rock and expel enormous amounts of material into space. The question is, how do we know this is happening? The answer lies in the peculiar way the light from its star dims when the planet passes in front of it. Unlike other exoplanets, the decrease in light is not always the same. Sometimes it is deeper, other times less so, and occasionally, the shape of the light curve is asymmetric. Astronomers deduced that Kepler-1520b is surrounded by a gigantic cloud of dust and debris, formed by the material that the planet constantly loses. It's as if Kepler-1520b leaves a trail, similar to that of a comet, but much denser and more chaotic. Can you imagine a planet losing so many fragments that, over time, it will simply cease to exist? It is estimated that Kepler-1520b loses hundreds of millions of tons of material each year. If it continues at this rate, the planet could completely disappear in just a few million years, a blink of an eye on a cosmic scale. This process offers us a unique opportunity to observe how a rocky planet, likely similar to Mercury in size and composition, disintegrates due to the extreme heat and gravitational forces of its star. It is a reminder of how hostile and dynamic the life of a planet outside our solar system can be. But what secrets does this disintegration hold? The study of the dust cloud and tail of Kepler-1520b allows scientists to investigate the internal composition of a planet outside our system, something that would be impossible otherwise. Every dust particle tells a story about the materials that make up these distant worlds. Ultimately, Kepler-1520b is much more than a doomed planet. It is a direct window to understand the most extreme and exotic processes that can occur in the universe. Can it rain iron in some corner of the universe? Although it may seem like an idea straight out of a science fiction novel, the answer is yes. WASP-76b is one of the most unusual exoplanets ever discovered, and its climate challenges everything we know about worlds outside the solar system. Located about 640 light-years from Earth, this giant gas planet exhibits such an extreme phenomenon that it seems impossible: rains of molten iron. But how is it possible for a planet to exist where iron can evaporate and then fall from the sky in the form of scorching droplets? It all begins with WASP-76b's proximity to its star. This exoplanet orbits so close to its sun that a year there lasts just a little over a single Earth day. As a result, temperatures on its daytime side exceed 2,400 degrees Celsius, enough to vaporize even the most resilient metals. Iron, which on Earth is solid and forms structures like bridges and buildings, becomes gas on WASP-76b, rising in the planet's scorching atmosphere. However, the spectacle doesn't end there. WASP-76b is gravitationally locked, meaning it always shows the same face to its star, just like the Moon does with Earth. This creates a brutal contrast between the daytime side, engulfed in unbearable heat, and the nighttime side, where temperatures drop enough for iron vapors to condense and precipitate. Thus, at the twilight border between both hemispheres, iron cools, transforms into tiny droplets, and falls like metallic rain. Imagine it, a downpour of liquid iron violently traversing the atmosphere, a scene that would make any terrestrial storm seem like a mere drizzle. And what implications does this finding have for science? WASP-76b not only challenges our imagination, but also theories about the formation and atmospheric dynamics of giant planets. Astronomers have managed to detect the presence of iron in its clouds thanks to sophisticated spectroscopic techniques, confirming that climates beyond the solar system can be much more extreme than we ever thought possible. This world reminds us that the planetary diversity of the cosmos is virtually infinite, and that, when it comes to exoplanets, reality can far exceed fiction. What if I told you there is a planet where temperatures are so high that even some metals could evaporate? This extreme place is Kelt 9b, known for being the hottest exoplanet ever discovered. But how much heat are we talking about? Temperatures in its atmosphere can exceed 4,600 degrees Celsius. That is, hotter than the surface of most stars. It is so scorching that iron and titanium, instead of being found in solid or liquid form, exist in a gaseous state floating in its atmosphere. How can this be possible? Kelt 9b orbits incredibly close to its star, to the point that it completes a rotation in less than 2 Earth days. That proximity means it is constantly bombarded by radiation so powerful that its atmosphere is in a state of almost perpetual boiling. If we compare it, it would be as if Earth were much closer to the Sun than Mercury currently is. Can you imagine an eternal and lethal summer where shade offers no relief? Another of the most astonishing features of this planet is its size. Kelt 9b is a gas giant, larger than Jupiter, but it suffers a constant loss of mass due to the intense heat from its star. What does this mean? The exoplanet is literally evaporating. Scientists estimate it could be losing thousands of tons of material every second, creating a sort of gas tail similar to that of a comet, although invisible to the naked eye. Could there be any type of life in such an extreme environment? The answer seems clear. The conditions there would be fatal for any form of life as we know it. However, Kelt 9b challenges our limits on what is possible in the universe. This planet not only breaks records, but also forces us to rethink our theories about the formation and evolution of worlds beyond the solar system. How far can the extremes of nature go? Kelt 9b is a reminder that in the cosmos, reality can be stranger and more impressive than any fiction. Is it possible that there exists a planet outside our solar system where the conditions are so similar to those of Earth that life could arise? Gliese 581c has been one of the exoplanets that has captured the imagination of astronomers and seekers of habitable worlds the most. Discovered in 2007, this planet orbits a red dwarf located just 20 light-years away from us, in the constellation of Libra. What makes Gliese 581c so special in the search for life beyond our home? To begin with, Gliese 581c is a super-Earth, meaning it is a planet larger than Earth, but much smaller than gas giants. Its mass is estimated to be at least 5 times that of our planet, suggesting it could have a solid surface. But what is most intriguing is its location. It lies right in the so-called habitable zone of its star, that magical belt where temperatures would allow for the existence of liquid water on the surface. Could this planet harbor oceans or lakes like those we know on Earth? However, the reality is more complex. Although Gliese 581c's distance from its star seems ideal, there are factors that challenge our optimism. For example, red dwarfs are much cooler and smaller stars than the Sun, but they tend to emit flares and radiation unpredictably. How would this affect a planet orbiting so closely? Additionally, Gliese 581c is believed to be tidally locked, meaning it always shows the same face to its star, like the Moon does with Earth. This would create one hemisphere scorched by constant heat and another shrouded in perpetual night, leaving a narrow twilight band where conditions would be less extreme. Despite these challenges, the possibility that Gliese 581c has an atmosphere capable of redistributing heat and even protecting a habitable zone cannot be ruled out. Can you imagine a world where the sunset never ends and life could adapt to such an exotic environment? This exoplanet forces us to broaden our idea of what it means to be habitable. Although we have not yet detected clear signs of life or water on its surface, the mere fact that it could be a candidate reminds us of how vast and surprising the universe is. Gliese 581c represents not only a scientific possibility, but also a symbol of hope in the eternal search for companionship in the cosmos. Is there a planet where the weather is so unpredictable and violent that it would make our earthly seasons seem like child's play? HD 80606b is that place. This exoplanet challenges everything we understand about weather on other worlds. It is a gas giant, similar to Jupiter, but with a peculiarity that makes it one of the most extreme exoplanets known. Its orbit is so eccentric that it resembles that of a comet more than a conventional planet. While most planets orbit their stars in roughly circular paths, HD 80606b has such an elongated orbit that it goes from being at a distance similar to that of Venus from the Sun to drifting as far away as Jupiter at its farthest point. What effect does this strange orbit have on its climate? The result is a climatic hell that erupts every 111 days when the planet approaches its star at an astonishing speed. During that brief and dramatic approach, the temperature of HD 8606b's atmosphere can rise by more than 800 degrees Celsius in just 6 hours. To put it in perspective, it would be like going from a winter temperature on Earth to one hotter than the surface of an industrial oven in a single afternoon. The upper layers of its atmosphere boil, expand, and generate supersonic winds that sweep across the planet at dizzying speeds. Have you ever wondered how these extreme changes were detected? Astronomers observed variations in the infrared light emitted by the planet before, during, and after its closest approach to the star. This allowed them to measure the brutal temperature spike and deduce the violence of its storms and winds. On HD 80606b, the climate does not change in seasons, but in bursts of heat that transform the planet in a matter of hours. The energy released during those moments is so immense that if it occurred on Earth, it would vaporize entire oceans. HD 80606b not only defies imagination, but also theories about how climate evolves on distant worlds. Can life exist in such a hostile and dynamic environment? Probably not as we know it. However, studying these extremes helps us better understand the diversity of planets in the universe and reminds us how small and privileged our own cosmic corner is. This exoplanet is a perfect example of how nature can repeatedly surpass the limits of our understanding. What makes a planet considered special within the vastness of the universe? Kepler-22b captured the attention of astronomers in 2011 when it was identified as a super-Earth located in the habitable zone of its star. But what does this mean exactly? A super-Earth is a planet whose mass is greater than that of Earth, but less than that of gas giants like Neptune. Being in the habitable zone means it is at the right distance from its star for, theoretically, liquid water to exist on its surface, one of the essential requirements for life as we know it. Can you imagine a world that receives a similar amount of light to what we experience here on our planet? Kepler-22b orbits a star very similar to the Sun, but its year lasts approximately 290 Earth days. Its size is about 2.4 times that of Earth, suggesting that its gravity would be significantly greater. Walking on its surface might feel like carrying a loaded backpack constantly. However, it is still unknown whether this planet is rocky like Earth, or if it has a thick layer of gas and water, which would make it a completely different world from anything we have experienced. Why does Kepler-22b generate so much excitement among scientists? The main reason is the possibility that it could harbor life. Being in the habitable zone and having a considerable size makes it one of the best candidates to search for signs of favorable conditions for life beyond the solar system. However, the great distance that separates us from this planet, over 600 light-years away, makes obtaining detailed information about its atmosphere and composition a significant challenge. How can we know if it has oceans, clouds, or even some type of climate? Although for now we can only speculate, the discovery of Kepler-22b opened a door to the hope that there are other worlds similar to ours in the galaxy. Each technological advance brings us a little closer to answering the fundamental question: are we alone in the universe? Kepler-22b, with its superior size and privileged location, remains one of the main enigmas and motivations for modern space exploration. What if there were a planet so dense that, if you could hold a piece of its surface, you would be astonished by its enormous weight? That is the case of Koro-T7b, the densest rocky exoplanet ever discovered. But what makes it so special among the thousands of known exoplanets? Koro-T7b was found thanks to the French space mission Corot, and from the very beginning, it puzzled astronomers with its extreme characteristics. This world is only slightly larger than Earth, but its mass is much higher, which means its density surpasses that of any other known rocky planet, even that of our own planet. Can you imagine walking on its surface? The gravity would be almost double what we experience on Earth. Every step would feel like carrying a backpack full of stones. Its density is so extraordinary that its composition must be primarily rock and metals, with almost no lightweight materials. If Earth were an apple, Koro-T7b would be like a bowling ball of the same size, much heavier and more compact. This planet orbits so close to its star that its year lasts only about 20 hours, which means it is subjected to extreme radiation and extremely high temperatures, likely exceeding 2000 degrees Celsius on its daylight side. How did Koro-T7b become so dense? Scientists believe that in its origins, it may have been a larger planet, perhaps with a thick atmosphere, or even a gaseous envelope. However, the brutal proximity to its star would have caused those gases to evaporate and escape into space, leaving behind only the rocky and metallic core. It's as if a gas giant had been stripped down to its mineral skeleton. This hypothesis makes it a unique window to study the extreme evolution of exoplanets and understand how hostile environments can sculpt radically different worlds from the ones we know. But the most fascinating thing about Koro-T7b is that it challenges our ideas about planetary formation. How did such a compact planet form, and why did it manage to survive so close to its parent star? Are there other worlds as dense and extreme waiting to be discovered? Or is this planet a cosmic rarity? Every piece of data that astronomers manage to gather about Koro-T7b helps answer these questions, while simultaneously opening new mysteries about the diversity and limits of the planets that exist in the universe. Koro-T7b reminds us that out there, the rules can be much stranger than we ever imagined. Can a planet have clouds of rubies and sapphires? Although it sounds like a scenario out of a fantasy story, science has shown us that the universe is much more extravagant than we imagine. HAT-P7b is a perfect example. A giant gas exoplanet located over 1,000 light-years from Earth that challenges what we believe is possible in nature. This world, the size of Jupiter but much closer to its star, is so extreme that crystals of corundum, the mineral that makes up rubies and sapphires on Earth, can form in its atmosphere. What conditions are needed for it to literally rain precious stones? The answer lies in the scorching temperature of HAT-P7b, which can exceed 2000 degrees Celsius. At these temperatures, the aluminum and oxygen compounds present in its atmosphere combine to form small particles of corundum. These particles, driven by the planet's violent winds, can condense and precipitate, generating clouds composed of these precious minerals. On Earth, rubies and sapphires are the result of millions of years of pressure and heat beneath the surface. On HAT-P7b, nature manufactures them in the heights, in a constant dance of formation and dispersion. Is it possible that there are storms of precious stones on this planet? Simulations suggest that yes, although it would be better not to be nearby. The winds on HAT-P7b reach speeds of several kilometers per second. capable of transporting these particles through the atmosphere with devastating force. Imagining this phenomenon is like thinking of sandstorms, but instead of tiny grains, the skies would be filled with microcrystals of ruby and sapphire, moving from one hemisphere to the other in an endless cycle. However, the beauty of HAT P7b is only superficial. Its extreme proximity to its star causes one side of the planet to be permanently oriented towards the fire, while the other remains in perpetual shadow. This thermal difference fuels the winds and violent atmospheric currents that keep the corundum clouds suspended. Wondering what the sky would look like from there is an exercise in imagination, but the reality is that HAT P7b is one of the best examples of the exotic variety of worlds that exist outside our solar system. The mere existence of a planet where clouds of precious stones might exist reminds us that the cosmos can always surprise us, and that nature has resources to create wonders we have yet to dream of. How old can planets outside our solar system be? If you thought exoplanets were recent phenomena in the history of the universe, Kepler 444 comes to challenge that belief. This planetary system has left astronomers perplexed. It formed over 11 billion years ago, when the universe was barely 1/5 of its current age. To put it in perspective, Earth didn't even exist, and the first galaxies were just beginning to shine. How is it possible that planets have survived for so long, in an era when heavy materials were scarce? Kepler 444 consists of an old star and 5 small exoplanets, all of which are comparable in size or smaller than Venus. Why is this so astonishing to science? Because these worlds formed long before the sun was born. It's like finding an intact city built before the invention of the wheel. The central star, an orange dwarf, is cooler and less luminous than our sun, but has witnessed nearly the entire cosmic history. Its planets orbit very closely, completing their orbits in less than 10 Earth days, which means their year lasts only a fraction of ours. Where did they get the materials to form, if at that time the universe was mainly composed of hydrogen and helium? That is precisely one of the big questions raised by this system. Rocky planets require elements like iron, silicon, and oxygen, products of previous generations of stars that exploded and enriched space. However, Kepler 444 emerged when these elements were extremely rare. This suggests that the formation of rocky planets may have been much more common and ancient than we imagined, opening the door to the possibility of civilizations that could have had billions of years to develop. What does this finding imply for the search for life in the cosmos? The existence of such ancient planets demonstrates that the ingredients for life have been available for most of the universe's history. If life emerged in some corner of Kepler 444, or in similar systems, it would have had an unimaginable amount of time to evolve. This system invites us to rethink our ideas about time, habitability, and the persistence of worlds beyond our own stellar neighborhood. Can a planet be pink? Although it sounds like science fiction, the answer is yes. GJ504b, discovered in 2013, is one of the most unique exoplanets ever observed. But what makes this world stand out among thousands of discoveries? Its pink color, so peculiar that it has been nicknamed the bubblegum planet. What causes this hue? The key lies in its temperature and the components of its atmosphere. GJ504b is a gas giant, much more massive than Jupiter, and orbits a young star located about 57 light-years from Earth, in the constellation Virgo. Its pink color does not come from flowers or exotic minerals, but from the way the heat of its atmosphere interacts with the molecules present in it. Its temperature hovers around 600 degrees Celsius, causing certain compounds, like methane and water, to absorb and emit light in such a way that the planet reflects that characteristic pink tone. It's as if the surface of a gas giant were illuminated by the light of an eternal sunset. What else do we know about this strange world? Unlike the giant planets of our own solar system, GJ504b is still very young, at only about 160 million years old. In astronomical terms, that's like a newborn. Thanks to its youth, it still shines with its own light, as it retains much of the residual heat from its formation. Astronomers compare this type of brightness to that of a glowing ember that has yet to extinguish, which makes its direct detection easier using advanced telescopes. And here arises one of the big questions. How did such a massive and colorful planet form at such a great distance from its star? GJ504b is located more than 40 times the distance between the Earth and the Sun, an orbit so distant that it challenges traditional models of planetary formation. Scientists still debate whether this pink giant was born close to the star and then migrated outward, or if it formed directly in its current location. This mystery makes GJ504b a key piece in understanding the diversity and evolution of giant exoplanets. Finally, what does the existence of a pink planet teach us? It reminds us that the universe is full of surprises and that the variety of worlds that exist far exceeds our imagination. GJ504b is proof that when it comes to exoplanets, reality can be even stranger than fiction. What other colors and unexpected phenomena await us in the unexplored corners of our galaxy? Is it possible that one day we will discover the secret heart of a giant planet, exposed like a cosmic relic? TOI 849b is a world that seems to answer this question with an enigmatic yes. Astronomers believe that this exoplanet, located about 280 light-years from Earth, is actually the bare core of what was once a gas giant, similar to Jupiter. How is it possible for a planet to lose its entire gas envelope and be reduced to just its core? The answer challenges our ideas about planetary formation and evolution. TOI 849b is comparable in size to Neptune, but it is much denser than one would expect. Its mass is almost half that of Jupiter, but its diameter is much smaller, indicating that it is composed almost entirely of rocky and metallic material. It's like finding the skeleton of a giant, stripped of all its flesh. What forces could have caused such a transformation? The main hypothesis is that this planet was once a gas giant, but due to its extreme proximity to its star, intense stellar winds and radiation stripped away, layer by layer, its entire atmosphere. What remains is the original core, normally hidden beneath layers of hydrogen and helium, now exposed to the vacuum of space. Can you imagine the violence of this process? The atmosphere of TOI 849b must have evaporated in a phenomenon known as photoevaporation, where the energy from the parent star is so intense that it literally boils and disperses the gases of the planet. It serves as a reminder that the universe not only creates worlds, but also transforms and destroys them in ways we are just beginning to understand. This exoplanet is, in a way, a time capsule. It allows us to directly observe the heart of a gas giant, something impossible in our own solar system, where the cores of planets like Jupiter and Saturn are hidden beneath thick layers of gas. The discovery of TOI 849b raises fascinating questions. How many other exposed cores may be hidden in the galaxy, waiting to be discovered? Could this process explain the existence of other dense exoplanets close to their stars? Furthermore, studying this world offers us clues about the internal composition of gas giants and the limits of planetary survival. In the end, TOI 849b reminds us that, in the cosmos, even planets can strip down to their foundations, revealing secrets that would otherwise remain buried forever. Is it possible for a planet to literally lose its atmosphere and leave behind a trail like that of a comet? HD 229458b, known among astronomers as Osiris, is the first exoplanet where this extreme phenomenon has been observed. This gas giant, located about 150 light-years away from us, orbits so close to its star that its year lasts just a little over 3 Earth days. But what happens when a planet lives so close to its sun? The answer is both fascinating and devastating. The intense radiation from the star heats the planet's atmosphere to temperatures exceeding 1000 degrees Celsius. This immense heat causes the atoms and molecules of hydrogen, sodium, and oxygen in the atmosphere to become excited and gain enough energy to escape the planet's gravitational pull. The result is that HD 29458b is literally evaporating, losing its atmosphere at a surprising rate. It's as if the star is stripping layer after layer from its atmosphere, leaving a massive tail of gas that stretches for millions of kilometers. Can you imagine a planet with an atmosphere so extended that it makes its own world look tiny? That's exactly what's happening here. Scientists have detected that the atmosphere of this exoplanet expands so much that it forms a gas cloud that could envelop the star itself. If we could get closer, we would see a kind of planetary ghost floating around its sun, with gases constantly escaping and glowing under the starlight. In fact, the mass loss of HD 29458b is so rapid that if it continued like this for billions of years, the planet could eventually disappear, leaving only a faint trace of its existence. How can we know all this if we have never visited that system? Thanks to advances in spectroscopy, astronomers can analyze the light that passes through the planet's atmosphere when it crosses in front of its star. This way, they have detected the escaping elements and estimated the rate at which the atmosphere is evaporating. This discovery has been key to understanding how a planet's proximity to its star can determine its fate. HD 29458b is a reminder that the universe is full of worlds where the rules we know are taken to the extreme, and where a planet's life can be much more fleeting than we imagine. Can an atmosphere reach the boiling point? In the case of WASP 121b, the answer is surprising. Yes, this exoplanet, located about 900 light-years from Earth, defies what we understand about extreme conditions. It is a gas giant known as an ultra-hot Jupiter, with an orbit so close to its star that it completes a full rotation in just over one Earth day. But the most astonishing aspect is not its size, but the state of its atmosphere. What happens when a planet is so close to its star that the heat literally boils its atmosphere? On WASP 121b, the temperature in the upper layers of the atmosphere exceeds 2,500 degrees Celsius, enough to vaporize metals like iron and magnesium. Imagine a world where the elements we consider solid on Earth exist here in vapor form, floating in the air. This atmosphere is not just hot, it's boiling, in the most literal sense possible. Astronomers have detected water molecules, but not as we know them, rather in the form of extremely hot vapor mixed with clouds of vaporized metals. What causes such an extreme phenomenon? The key lies in the distance. WASP 121b is so close to its star that tidal forces deform it, stretching it like a rugby ball. This proximity also means that the planet always shows the same face to its star, a phenomenon called tidal locking. As a result, the temperature difference between its day side and night side is staggering. Winds, driven by this thermal contrast, carry metals and vapors from one hemisphere to the other, creating a brutally dynamic atmospheric cycle. Can you imagine a planet where metals travel back and forth in gas form, swept along by supersonic winds? The gravity of WASP 121b is weak compared to the scorching force it receives from its star, causing part of its atmosphere to literally evaporate into space, forming a kind of giant, diffuse halo. This process has been directly observed by space telescopes, demonstrating that the planet is losing mass at an alarming rate. Essentially, WASP 121b is being stripped of its atmosphere as if it were a boiling pot without a lid, releasing its components into the interstellar vacuum. WASP 121b represents a unique natural laboratory for astronomers, a place where the laws of physics manifest in their most extreme version. The study of this planet not only shows us how far the diversity of worlds in the universe can go, but also challenges our ideas about the stability and longevity of giant planets. If you've ever wondered what it would be like to live on a planet where the air is so hot that metals evaporate, WASP 121b is the closest answer that modern astronomy offers. What makes a planet truly promising for life? LHS 114b is one of the exoplanets that has excited the scientific community the most in recent years. It is a rocky world orbiting a red dwarf star just 40 light-years from Earth, a relatively close distance in astronomical terms. But why does this planet stand out among thousands of other candidates? The answer lies in its combination of size, composition, and above all, its privileged location within the habitable zone of its star, that golden ring where the temperature allows for the existence of liquid water. LHS 114b is about 1.5 times the size of Earth and nearly 7 times its mass. This density suggests that it is a solid planet, likely composed mainly of rock and iron, just like our own planet. Could it then harbour seas, lakes, or rivers? Astronomers have detected hints that it might have a dense atmosphere, which would be crucial for maintaining water in a liquid state. Such an atmosphere would also serve as a shield against the dangerous radiation emitted by red dwarf stars, known for their frequent eruptions. However, the real mystery is whether that atmosphere actually exists and what it is composed of. What are the chances of finding life in a place like LHS 114b? Science still cannot provide a definitive answer, but the factors are intriguing. Its year lasts only 25 Earth days, which means the planet is very close to its star. This could lead to one of its hemispheres being permanently illuminated and the other shrouded in darkness, a phenomenon known as tidal locking. If that were the case, the most habitable zone could be the middle band, where light and darkness meet, generating more moderate temperatures. It is in that delicate balance where scientists dream of possibilities: temperate oceans, clouds, perhaps even a climate conducive to life. What is truly fascinating about LHS 114b is that it represents a unique opportunity to study a rocky world outside the solar system with increasingly advanced technology. Missions like the James Webb Space Telescope are already setting their sights, or rather their sensors, on this planet, trying to decipher the secrets of its atmosphere. Will they detect water vapor? Will they find signs of life-related molecules, such as oxygen or methane? Each new observation brings humanity a little closer to answering one of the deepest questions we can ask. Are we alone in the universe? Or is LHS 114b just one of many worlds where life could be waiting to be discovered? Are there planets in the universe that are almost a reflection of Earth? Kepler-20z and Kepler-20f are two exoplanets that have fascinated the scientific community as they are considered the first Earth twins discovered outside our solar system. But what does this nickname really mean? Both planets orbit the same star, Kepler-20, located approximately 950 light-years away in the constellation Lyra. What is truly astonishing is that their sizes are remarkably similar to that of Earth, a rarity among the thousands of exoplanets detected so far. Could these planets harbour life as we know it? Kepler-20z has a radius just slightly smaller than that of Earth, while Kepler-20f is just a bit larger. This similarity has led many to wonder if they could be habitable places. However, the reality is more complex. Both are much closer to their star than Earth is to the Sun, in fact, even closer than Mercury. This implies that the temperatures on their surfaces would be extreme, making the presence of liquid water impossible, at least under the conditions we know. Still, the mere existence of rocky, Earth-sized planets in other stellar systems has opened a new chapter in the search for other worlds like ours. What does the discovery of these twins tell us about the formation of planetary systems? Until their detection, most of the exoplanets found were gas giants, much larger than Earth. Kepler-20z and F demonstrated that small rocky planets are not exclusive to our cosmic neighborhood. It's as if the universe is whispering to us that, in the vast lottery of planetary formation, the winning tickets for worlds similar to ours can appear anywhere, even in systems with architectures very different from that of the solar system. The key question remains: is there any chance that these planets could be habitable in the distant future? Models suggest that if they ever had dense atmospheres or water, they likely lost them due to the intense radiation from their parent star. However, their existence is a promise for astronomers because it reminds us that the ingredients for building Earth-like planets are present in many places in the cosmos. Every time we find Earth twins, the hope of discovering a truly habitable world grows, driving us to continue exploring the secrets of the universe. Is it possible to observe gas giants outside our solar system clearly enough to see them as a family? The HR 879 system answers this question with a resounding yes. This system, located about 130 light-years from Earth in the constellation Pegasus, became a milestone in modern astronomy by being the first directly imaged multiplanetary system outside the solar system. But what makes HR 879 so special beyond this technological feat? Imagine a solar system where 4 colossal planets, all gas giants, orbit a young star that shines with twice the mass of our Sun. These planets, known as HR 879 B, C, D, and E, are between 5 and 10 times more massive than Jupiter. But the most surprising aspect is not just their size, but also the distance at which they orbit their star. Some of these planets are as far from their Sun as Pluto, or even beyond in our own system. How can such massive planets form and remain so far from their parent star? This question continues to puzzle astronomers. Unlike the planets in our cosmic neighborhood, the giants of HR 879 have wide and at times chaotic orbits. Scientists compare their orbital dynamics to a kind of cosmic dance, where each planet influences the movement of the others. It's as if a family of elephants is trying to dance on an ice rink. The movements are unpredictable, but the balance is miraculously maintained. Could these planets collide or be ejected from the system in the future? There is still no definitive answer, but models suggest that the system could be stable for hundreds of millions of years. Another fascinating aspect is the youth of this planetary system. HR 879 is only about 60 million years old, which in cosmic terms is like a newborn. This youth allows astronomers to observe planets in an early stage of their evolution, when they still shine with the residual heat of their formation. What can we learn from these incandescent worlds? Observing HR 879 is like looking at a photograph of the childhood of our own solar system, a portrait that could help us understand how planetary systems form and evolve in the universe. Is it possible that there is a planet outside the solar system with water in its atmosphere, and that it also has the right conditions for life as we know it? K2-18b has caught the attention of astronomers and cosmos enthusiasts precisely for this reason. Discovered in 2015, this exoplanet orbits a red dwarf star about 120 light-years away in the constellation Leo. Its size is approximately twice that of Earth, classifying it as a super-Earth or mini-Neptune, a category of planets that does not exist in our solar system and that provides clues about the diversity of worlds in the universe. One of the greatest mysteries of the universe is the presence of water on other planets. In the case of K2-18b, scientists were able to detect water vapor in its atmosphere using the Hubble Space Telescope. Why is this so revolutionary? Until recently, the search for life beyond Earth focused on finding planets with suitable temperatures and rocky surfaces. But now we have taken a step further, finding direct evidence of one of the fundamental ingredients for life. Just as water is essential on Earth, its presence in the atmosphere of K2-18b opens the possibility that clouds, rain, and perhaps even oceans exist beneath a thick, gaseous layer. However, could we really find life there? Although K2-18b is located in the so-called habitable zone, where temperatures would allow for the existence of liquid water, its environment is very different from that of our planet. Its atmosphere is likely dense and rich in hydrogen, creating a kind of gigantic greenhouse. If we imagine Earth covered by a perpetual fog and with overwhelming atmospheric pressure, we would have a rough idea of what it might feel like on the surface of K2-18b. Additionally, its star is a red dwarf, much cooler and more active than the Sun, which means the planet receives varying levels of radiation, a factor that further complicates the possibility of life as we know it. The question remains, could there be organisms that adapt to such alien conditions? The answer is still uncertain, but the detection of water makes K2-18b one of the most interesting candidates for future research. Science is advancing by leaps and bounds, and in the coming years, more powerful telescopes like the James Webb could analyze the composition of its atmosphere in greater detail and search for possible signs of biological activity. Ultimately, K2-18b reminds us that the universe is much more varied than we imagine, and that perhaps life could thrive in places we currently consider impossible. If you've ever wondered if there is a planet similar to Earth, but larger and perhaps older, Kepler 452b is probably the most fascinating answer science has provided so far. Discovered by the Kepler Space Telescope in 2015, this exoplanet has been dubbed the older cousin of Earth. Why does it cause such a stir among astronomers and astrobiologists? Because it possesses several characteristics that make it an intriguing candidate for harboring life, or at least for understanding how life might evolve on other worlds. Kepler 452b orbits a star very similar to the Sun, but which is 1.5 billion years older. This means that this planet has been in the habitable zone long enough for complex biological processes, if they were to arise, to have had a chance to develop. But what does it mean to be in the habitable zone? It is the region around a star where temperatures allow for the existence of liquid water on the surface of a planet, an essential ingredient for life as we know it. Kepler 452b meets that requirement, and it is also approximately 60% larger than Earth, classifying it as a super-Earth. However, size has interesting consequences. Could a planet larger than Earth really be habitable for us? A planet of this size would likely have greater surface gravity, making movement more difficult for any form of terrestrial life. Additionally, its atmosphere could be denser, altering the climate and surface chemistry. But these same conditions could favor climate stability and provide better protection against cosmic radiation. It's like comparing two houses. A larger one has more space and protection, but it also requires adaptations to live in it comfortably. Another intriguing question is whether Kepler 452b actually has liquid water and a breathable atmosphere. So far, technology does not allow us to observe these details accurately, but models suggest that if it is a rocky planet like Earth, it could have active volcanoes, extensive oceans, and perhaps even continents. The great age of its star raises another dilemma. Is this older cousin entering a stage where its climate becomes less stable and its atmosphere begins to dissipate? Or is it at the optimal point for the flourishing of life? Scientists continue to debate these possibilities because every piece of data about Kepler 452b offers clues about the future of Earth and makes us question what a similar planet to ours really means. In summary, Kepler 452b is much more than a mere astronomical curiosity. It is a window into what could be the fate of our own planet, and a reminder that the universe is filled with worlds that, although similar, may have completely different stories. Could this be the place where we someday find signs of life? For now, it remains a mystery, but one that motivates humanity to look to the stars with renewed hope and curiosity. Gliese 436b, known as the hot ice planet, is one of the most puzzling worlds ever discovered outside our solar system. How is it possible for ice to exist in a place where temperatures reach over 700 degrees Celsius? This paradox has fascinated astronomers around the world and forces us to rethink everything we believe we know about the physics of planets. The key to this mystery lies in the incredible pressure that exists on the surface of Gliese 436b. This exoplanet orbits very close to its star, a red dwarf located about 33 light-years from Earth. Due to that proximity, it receives an enormous amount of heat, much more than Mercury does from our Sun. However, the gravity of Gliese 436b is so strong that the water on its surface cannot evaporate or melt in the way we would expect. Instead of turning into vapor or a boiling ocean, the water transforms into what scientists call superionic ice, or hot ice, an exotic state in which the molecules remain organized and solid despite the extreme heat. Can you imagine walking on a frozen lake where, instead of feeling cold under your feet, the heat would be scorching? That's how the strange surface of this planet could be described. Hot ice is nothing like the ice we know on Earth. It is dense, dark, and its oxygen molecules form a rigid structure while the hydrogen ions move freely, as if they were an electric current trapped in a glass prison. This combination results in a substance so exotic that it has only been reproduced in laboratory experiments under extreme pressures and temperatures. Gliese 436b also challenges our understanding of planetary formation. How can a planet retain water in solid form under such conditions? Current models suggest that this world may have migrated from colder, more distant regions in the past, trapping large amounts of water before moving closer to its star. Its existence demonstrates that exoplanets can surprise us with phenomena we never even imagined possible. This planet is proof that when it comes to alien worlds, the rules of physics can be written in much stranger inks than we might assume from the comfort of Earth. What if there were a planet so close to us that, in cosmic terms, it would be almost our next-door neighbor? That is the case of Proxima Centauri b, the closest exoplanet to Earth. Orbiting around Proxima Centauri, the closest star to our Sun, this world has captured the imagination of scientists and the curious alike. But what makes Proxima Centauri b so special? Could it be the best candidate for searching for life beyond our solar system? Proxima Centauri b is located just over 4 light-years away, a figure that seems like a mere breath in the universe. To put it in perspective, if our solar system were a house in a gigantic neighborhood, Proxima Centauri b would be just across the street. This exoplanet has a mass similar to that of Earth and orbits within the so-called habitable zone of its star, meaning the region where temperatures could be suitable for liquid water to remain on the surface. Does this mean there are oceans or even life? Not necessarily, but it's an excellent starting point. However, the story of Proxima Centauri b is far from simple. Its host star, Proxima Centauri, is a red dwarf much smaller and cooler than our Sun, but it is also much more active. This star emits intense flares and ultraviolet radiation, which could make the planet's atmosphere unstable or even cause it to evaporate over time. Could Proxima Centauri b protect itself from these onslaughts with a magnetic field like Earth's? That is one of the great mysteries that scientists are trying to solve. Another fascinating fact is that, due to its proximity to its star, Proxima Centauri b is likely tidally locked. This means it always shows the same face to its star, just as the Moon does with Earth. Thus, one hemisphere would be eternally illuminated while the other is plunged into perpetual night. Could life develop in the twilight zone between light and darkness? It's a question that evokes as much mystery as hope. Exploring Proxima Centauri b is, for now, a distant dream. Even with the most advanced technology, a journey there would take tens of thousands of years. However, its proximity makes it the ideal destination for future interstellar missions and the search for signals of life. Proxima Centauri b reminds us that, in the vastness of the cosmos, we may have neighbors much closer than we imagine, and that the next great discovery could be waiting just on the other side of interstellar space. Can the universe harbor worlds so strange that even our most advanced scientific models fail to explain their existence? There are exoplanets that seem to mock the known laws of physics and planetary formation, defying astronomers' expectations at every turn. How is it possible for gas giants to exist in impossible orbits, or for planets to have characteristics that seem straight out of science fiction? These extreme cases are genuine enigmas for modern science and remind us of how little we know beyond our cosmic neighborhood. Some of these exoplanets have orbits so eccentric that they are almost incomprehensible. What force could have thrown a planet into a trajectory so far from its star, as if it were a lost ball in the vastness of space? There are examples of worlds that orbit at distances thousands of times greater than that of Earth to the Sun, in paths that defy any logical explanation based on current planetary formation models. Others, on the other hand, seem to have formed close to their star, but exhibit chemical compositions suggesting they should have been born much farther away, in the cold regions of the system. Even more perplexing are the exoplanets that orbit dead stars, like pulsars, in environments so violent that, according to what we know, any material should be destroyed in seconds. How could these planets survive stellar cataclysms that obliterated everything around them? The existence of worlds with atmospheres that evaporate at incredible speeds, or that show signs of enormous electrical storms, tests our ability to understand the physics of other solar systems. Some even appear to be composed almost entirely of materials that, in theory, should not be stable under those conditions. Every time astronomers detect one of these extreme exoplanets, an inevitable question arises. Are we witnessing unique phenomena, or have we barely scratched the surface of the planetary diversity of the cosmos? When a theory fails to explain an observation, it does not mean that nature is wrong, but rather that our understanding is still limited. These mysterious worlds force us to rethink what we believe we know about the origin and evolution of planets, and invite us to imagine what other surprises await us in the hidden corners of the universe. What unsuspected secrets do the planets we have yet to discover hold? What does the incredible diversity of exoplanets discovered so far reveal to us? First of all, that the universe is much stranger and more fascinating than we ever imagined. There are worlds where it rains glass, where iron falls from the sky like raindrops, and planets with such extreme temperatures that they defy all logic. Who would have thought that some planets could be darker than coal, or have clouds made of rubies and sapphires? Each of these findings forces us to rethink what we believe we know about the formation and evolution of planetary systems. Is it possible that there is life on any of these exoplanets? That is one of the most intriguing questions that science seeks to answer. If in our own solar system there are planets so different from one another, why couldn't there be favorable conditions for life in some distant corner of the cosmos? Exoplanets located in the so-called habitable zone ignite our imagination and drive us to search for signs of water, atmospheres, and who knows, perhaps even civilizations completely different from our own. Just like when exploring new continents on Earth, each discovered exoplanet is like an unknown island in an infinite ocean, full of possibilities to explore. But how far can we go in the search for these worlds? Detection and observation technologies have advanced by leaps and bounds. Thanks to space telescopes and innovative methods, astronomers can detect planets thousands of light years away, analyzing tiny variations in the light of stars, or even capturing direct images. It's like trying to find a firefly next to a lighthouse on the coast of another continent, a task that seemed impossible just a few decades ago. However, today we know that there are thousands of confirmed exoplanets and that the universe could harbor trillions of them. Will the discovery of a particular exoplanet one day change our view of life and our place in the universe? Undoubtedly, each new strange planet added to the list reminds us of how small we are and how little we know about the cosmos. The search for exoplanets is not only a scientific race, it is also a journey of self-discovery. It forces us to look outward and at the same time to reflect on the uniqueness of our own planet. Perhaps somewhere in that vast stellar sea there exists a second Earth, or something even more astonishing, waiting to be discovered.